Hi, I'm Joseph Schlesinger.
And I'm Connie Hugh.
And this is Sparky! Sparky is a simple-to-use, open-source, Arduino-based robot. The lowest-cost full-featured robot on the market. And is an engaging introduction to programming, electronics, and robotics.
Sparky is very easy to use and to get started with. Just take it out of the box, plug it in, download our customized Arduino software, and get started with any of our dozens of programming samples. Or you can write your own code in minutes using our online tutorials. We've been conducting pilot classes with elementary and middle school students and have been amazed at what they can do. We are working hard on enhancing and expanding our curriculum for Sparky, improving the lessons and code used in the class. Sparky is easy to use for the beginner.
Yet feature-packed enough for even the most passionate enthusiast or researcher, and is aimed at anyone looking to learn these subjects or to have a comprehensive robotics platform for their own projects and experiments. Sparky includes a servo-mounted ultrasonic distance sensing head, 3 light level sensors,
a 3-axis accelerometer to detect the current angle of the robot, 5 line following and edge detection sensors,
infrared send and receive modules for inter-Sparky communication, and to use with the included remote control, a 128 by 64 pixel graphic LCD.
And 2 geared stepper motor wheels for highly precise measured movement, which, when combined with Sparky's center-mounted marker holder, allow you to do some amazing drawings.
If we raise enough to reach our 200K stretch goal, we will include a multi-channel data radio, perfect for coordinating multiple Sparkies to do swarm robotics.
Sparky's durable ABS plastic construction, same plastic used in Legos, will also be made with a special textured injection mold technique so that you can easily draw on it with markers.
Simply put, you can have Sparky do anything you've ever wanted a robot to do for you. Thanks to our last completed and fully shipped Kickstarter, we've demonstrated the experience in sourcing, distribution, and manufacturing necessary to complete this project.
It's also given us the time to develop Sparky for close to a year, through an evolution of dozens of prototypes, and working with our manufacturing partners to refine our current version for months. And as always, in keeping with Artbotic's open source philosophy, all designs for the robot will be released online.
I am Chris Hakim, a self-taught engineer in Silicon Valley with nearly 30 years of experience in electronics and computer programming. The smartphone wars have made crucial balancing robot components, such as accelerometers and proximity sensors, affordable and readily available. With those, I have devised a low-cost balancing robot to be used as an educational platform for hacking and for fun. It is Arduino compatible and has plenty of unused memory and CPU power for you to experiment. For the more advanced student, there are plenty of challenges working with balancing robots, even for engineering graduates. There's plenty to learn about Littlebot. Littlebot hardware and software are open sourced. Littlebot can be powered by alkaline batteries, by rechargeable nickel metal hydride batteries, or by Open Fuel Cell's new fuel cell shield for Arduino. Do you ever wonder how a robot feels? Littlebot can express a range of emotions through an optional Arduino-compatible emoticon shield. For the younger child, LittleBlocks provides an easy and intuitive graphical programming environment as an alternative to Arduino's traditional C and C++.
Arduino is an Arduino-compatible balancing robot. And as you can see, it consists of some different parts. Mainly, we have 3 layers of laser-cut plywood, each assembled with a solid and strong steel rod. At the bottom, we have 2 high-torque and high-speed 12-volt DC motors, each with an individual rotary encoder. Mounted to the motors, we have 2 rubber wheels with high friction and great for indoor use to keep the robot balanced. At the top, we have an 3S 11.1 volt LiPo battery that is connected to the main board and drives the motors. The weight of the LiPo battery is also used as a counterweight for the robot to keep it balanced. At the bottom layer, we have the main board, the Arduino compatible controller board that consists of an Atmega 644 microprocessor. Connected to the microprocessor, we have an NPU 6050 3-axis accelerometer and gyroscope. Furthermore, we have a USB host controller to interface with some different peripherals, and we have 2 motor controllers for controlling each of the motors.
The main purpose of the USB host controller is allow you to control the robot with your favorite game controller, PC or Android phone. We've already written the necessary code which will allow you to control the robot with the most popular game controllers, the Xbox, Wii and PS3 controller. In order to use the Xbox controller, you will need a wireless USB dongle. This can be found relatively cheap online. To use either the Wii mode or the PS3 controller, you need a Bluetooth dongle which will be included in the kit for free. The PS3 and Wii mode can be used at the same time using the same Bluetooth dongle. Furthermore, we have written a PC application in Java compatible with both Windows, Mac and Linux. We have also written an Android application to go with the kit, so you can easily both remote control the robot and adjust some different settings.